Alright, so let's do this. Sound might be a bit off because I didn't have time to pair my new headphones. I lost my other headphones, so I had to buy new ones, and so I didn't have the time to pair them in time. And I'm really short on time, so if I want to do the stream, I had to start it now. So, anyways, I hope the sound won't be too bad. Let me go and see if visuals on that. It looks alright. So I guess I'll see after. I did some reviews on the setup here, so we should be able to zoom a bit. So we have the chip map here still on the middle right screen. I have another setup where we can see from the back cam there, another setup where we can go and see from the microscope on the main screen, microscope on the right middle screen. So we'll be able to play around a bit more with the configuration here for the stream, and hopefully it's going to make it a bit better to explain. So I had this board here. I had a request on YouTube and on Discord to fix some T17s that have temperature sensors issues. Obviously, we have like hundreds of boards that are still waiting for repairs, and we do have those boards where we did a bit similarly to the situation that was explained to me, where we fixed an issue. So in this case, this board, we fixed this chip that had an issue. Now, if we go ahead and test that board, we'll see that the signal is passing through from the first to the last chip, but we still have some temperature sensors issues. Now, in my experience, most of the times it's not the actual temperature sensor I see that's causing that issue, but it's really a chip. Normally, it's a chip from a domain that's touching temperature sensors that's causing the issues. So either here or here. I believe on this board, and we'll go and see and measure, obviously, but I believe the temperature sensors in the unit, they were giving issues to one of those two chips here on that domain. So the guys that run the test, they identified that board for me to let me know that, you know, in the machine, it doesn't go, the temperature sensor fails after some time. So let's go ahead and just start with a chip test there on the hashboard. So I'm starting my power supply at 21 volt, and let's launch the test. And yes, we have all the chips. So the chip problem on this board, this chip here, was properly fixed. But now let's go ahead and call on the temperature sensors to see what it says. That's okay, cool. I'm really sorry about that. If this stream is too bad for the sound quality, maybe I'll redo another one in the future. So yes, again, we can see here that the actual issue really is on that domain. So with the ARC tester, since one of the latest update they did, they have those flashing temperature sensors here. So if I go and hover over it with my mouse, I'm going to be able to see that the temperature sensor is actually replying, but it's replying with a temperature that doesn't make sense. In that case, the PCB reading is at minus 64 degrees. And if we go to the second one here, we have the same thing. So temperature sensors are there, but their readings are off. And obviously the machine at minus 64, it won't hash. So let's actually keep that test running, and let's start the multimeter. Let me bring the multimeter on screen. Let's try to better view on the multimeter. And we'll start reading some values. So again, my expectation is the problem is going to be a chip. So the chip is passing the signal, but there's probably a chip that's a bit off if we look at the values. Let's go ahead and measure that. So I'll start, we're going there. So I'll start actually from that chip 21 that was changed. So maybe this chip that was changed is causing the issue. I guess at 95, this is a very high reading, and as soon as I measure it, everything is going away. So it's very possible that the chip that was used to fix that board is actually not good. Let's keep on making some readings. 87 on the 22nd chip. Oh, and let me bring it maybe with the microscope so you can see a bit better how we make the measurements. That should do it. All right. So I'm measuring my clock like this. So I'm grounding on the 20-second chip, measuring my clock, and my reading is at 95, 0.95. Normally we should be aiming for values between 0.7 and 0.9, and so that's probably the issue. I can see now that with this setup the multimeter is not so obvious on the screen, so I'll need to wear something to bring my camera to a good angle so we can have a better view of the numbers on the screen. The next one, 87, 89, keep going like that, 89, 90, that should just 86, and 93. So this one is a bit high too. Let's bring it back like that. All right, so this one here is high too. Actually, 92, 93, yeah. So let's start with those readings. Let me find it. There we go. So this one that was already replaced looks a bit weird, and this one. Yeah, I'm testing voltage at the moment. So most of the times I'll be looking at voltage, but we can also, for temperature sensors issue where your signal is passing through, but you can also look at the resistance values. So I'll do that just after I remove those heat sinks there. Let me just bring some fans to cool down the board. It's back on screen like that. Let's go for the diode test. Now the board is still a bit hot, so I'll wait before starting to measure my resistance, because obviously the heat that gets into the chip can influence the values a bit. And so when we're measuring diode, you have to remember you have to invert how you would normally make your measurement. So normally you would use the black probe to ground yourself, measure with the positive probe, the red one. But now you're injecting that voltage to make the measurement for the resistance. So you actually have to ground with the red probe and measure with the black probe. So that's hot. Let me give it more. If you're using Bitmain's test jig, when you're doing the chip level testing, you can do it like I'm doing. But if you're doing the pattern testing, remember to have actual fans connected to your tester, because it needs to cool down a lot. The boards, they get very hot when they do the pattern testing. Unlike this tester, the hard tester, which uh, the chips, they get hot, but really not nearly as hot as they do with the pattern test. That should be good. So let's go and measure from here. We'll look at the clock again. I'm getting a reading of 1193. So this is within values. We're looking at 1200 plus or minus 20. Give or take. When I see a difference of about 30, normally I will let it go through. But yeah, give or take. Measuring the clock. So see, in this case, I'm having 1170. So there's a difference of about 30. It doesn't still look too bad. Now this one in the middle, the difference is starting to be a bit higher. I'm getting 1159. So let's keep this one in mind. 1150. So it seems to decrease for some reason. But also there's another thing is the ground on the top of the chips, because of the delamination issues, sometimes grounding on the top of the chips isn't too perfect. So you can always come use your red probe, and you can come anywhere here. You can come and inject your voltage for the measurements of the resistance directly to the ground of the board and make your measurements. So let's go and measure here. And now I have 1150 on the clock. 1145, 1145, 1141, 1140, 1140, 1154, 1165, 1165. So I measured difference with the voltage test on those two chips. So far, these are the values that are the most off. So these are the two first chips that I'll start getting rid of. And weirdly enough, this chip was changed to face the signal on the board. But the first place where I could measure 95 volt was this one here. So maybe there's something. And my issue is necessarily located somewhere around those three domains here. Those three domains, because the domain with the temperature sensors is this one, and in my experience normally it's either one of the domains attached to the temperature sensor or the domain that has the temperature sensors. So I'll be really looking at my troubleshooting here, and in that area it's the only two chips that I could find weird values. So let's go and try to change that. For voltage, yeah. So voltage, the values you'll be looking for when you're measuring the voltage, you'll be looking at the clock. You'll be looking for between 0.7 and 0.9. So 0.70 and 0.90. If you look at the return signal, so this one is the RI. At this one, you'll be looking at 1.7, give or take about 0.1. So if you have 1.6, that's good. If you have 1.7, that's good. If you have 1.8, that's good. BI, you shouldn't be seeing nothing on your BI except a small bump of noise when you test with a return signal. So what I mean by that, with reset actually. So when you're setting some reset cycles, which you can do with the arc tester, you should be seeing some noise on the BI, like small bumps on the readings. But normally your BI is going to be at 0. And then what other signal is really important? Well, you have your TX 1.7, again, give or take 0.1, so 1.6, 1.7, 1.8. And that's essentially the signals that I'm looking at when I have issues, when it's temperature sensors issues at least. Normally, I really go and look for the clock and the reset. In that case, with the clock, I could already see my issue. But the BI is also practical sometimes. So you know what? Let's put our multimeter back into voltage mode, and let's measure BI just to see if we have any noise. Like that. When you're injecting the voltage from a variable power supply, really you have to remember, you normally the best practice is to connect the negative probe first, then the positive one. You have to remember one trick that I have. Let me remove the multimeter for now from the screen. One trick I have is I always get my negative probe the closest to the IO port. So if you look at S17 plus, the IO port is going to be up of the two power plugs there. So you're going to want to plug your power light like that, your black probe and then your red probe. But in that case, the closest one to the IO port is down. That's how I place it. And just to show you what I'm talking about, if we put a S17 plus on screen, you can see the IO port is up. And so the rule of thumb is the negative probe here and the positive probe there. So it's a quick way at first sight to know which of the poles to use. Now let's go and measure. Plug my IO port. So on the tester screen we should be, yeah, we're resetting, and we'll launch the test now. With the ARC tester, normally when you want to hunt for some BI signal, you're going to want to make your testing in advanced mode. So now my tester is in standard mode. I'll launch the advanced mode, which is pulling data from each of the chips. So the difference between the normal mode and the advanced mode on ARC tester is that standard mode is just going to look for a chip count, and obviously if it gets to 30 chips, well, it means it's receiving replies from 30 chips. But let's say you have 27 chips. It doesn't necessarily mean that the signal is breaking at the 27th chip. It could be some ghost chip in between that you'll need to short to find out. And the advanced test mode, it's pulling the data from each of the chips. So in that case, most of the times when you have an issue, the advanced mode will fail. Now, let me just start that test over again because it seems that it bugged a bit. Maybe I went too fast. So again, I'm a bit short on time, so I'm trying to squeeze that stream in my schedule. And now I have some funny issues on the 15. Let's start again over. This is weird. So still at 21 volt. Everything is plugged in right. My dashboard is warm. Okay. Let's pull from the temp sensors and measure. Try to put on the light on the multimeter, but I don't think with that angle you'll be able to see much. Yeah, you can maybe, yeah, you can see a bit. All right, we have it. So let's go. BI, we're going to want to look from here. Now our clock, can we see? Let me zoom on that. So this is our clock, like that. And our BI is the complete opposite. So this is the one. So when I'm looking, I should be measuring 0. I'm seeing 0.04, 0.03. So there's a bit of noise. Really, it shouldn't have any noise at all. except from when you have resets. So clock is normal here. And this, you see this one, the BI is much more normal. So here's our clock. Reading is normal. And if I go and look at the BI, I'm having 0.003, and sometimes I have small bumps that goes to 0.22. So this is normal. The bumps are normal, and we're essentially like the 0.005 that I'm measuring is probably just noise from my actual multimeter. So let's see. When I'm measuring just the two probes together, I can get 0.003. So there can be some noise coming from your multimeter. So this is very normal. But on that chip here, let's go back to that chip here, clock, which is high, and BI, I'm always having some noise. I'm not sure if you can see it on screen. Let me put back the light on the multimeter. Hopefully you can see, but the BI always, there is a small glimpse of noise. Now, if you had an oscilloscope, I don't have it in my office now, but if you have an oscilloscope, you should be able to see that noise. So an oscilloscope is always fun to have because you're able to actually look at the signal and it makes you understand some stuff. So it's practical to have and to understand what's happening on the board. But with the measurements and with your multimeter and with experience, you should be able to find those issues. And just for fun, let's try to see at the return speed. I'm getting 1.775. So this is, the return is normal. So let's stop the test. Power off the power supply. Let's go back to our main screen. This out the way. All right. Right there. And so this chip, there was an intervention there, and the signal is not perfect. So my first bet is to change that chip. We'll put some flux, and we'll heat. Cool down a bit the pads, then we'll clean and install a new chip. Now, one more thing I should have done before removing that chip actually is to measure the resistance as well that are in the way of that chip, of that signal. But my first bet would be that the chip installed was not perfect. Everything is clean there. Let's still measure the resistance there. Again, let's go with the multimeter and the microscope. that. So I'm getting 31.9, essentially 33. We're looking for 33 on those three resistance there. Those three resistance, they should be at 33. So I'm getting 31.9. This is within range. 32. And 33. Amazing. You can always look at this one here on the top. 32.1 within range. And in the Discord, I was talking also about the 04, 02 resistance, which are these two resistance there. So if we go, bring back the light here to give you a chance to maybe see the values. So let me put back my probes, because with the heat sinks all around, harder to go and grab. So this one here is essentially 1K. We're measuring 1K. Right now I'm measuring 0.998. So this is 1K essentially. And if we look at this one here, here I'm getting essentially 10K, which is the right value. I believe I said those two were 1K in the Discord channel, but actually this one is 1K and this one is 10K. My mistake. And this is good values. You have 1K and 10K, which is good values. I'm measuring 9.91 within values, within range. This is good. The same here. Five there. Five there. All right. So let's put some flux and install a chip. So I have some recycled chips that I'm going to be using for that one. I believe those chips should be good. So let's try that out. Yeah, that's made some tweaking to the setup. So Alex says, yes, big screen microscope. Still have to do some optimization, I think, on the setup, but it's getting better and better. And obviously, if you have any comments, anything that I should do to make this better, do let me know. I'm a bit in a rush today, but I'm trying to make those streams better each time. And we had Ahmad, our one of our technicians here in the Quebec facility, that did the last stream. He's probably going to do more in the future. We're going to have a microphone for him and for myself as well, so we can hear him more because he was a bit low on volume. But you could see, if you go back and look at the stream number 3, you can see this guy is very talented. I'm very glad to have him in my team. And we'll have some more of our technicians do streamings as well. Obviously, I do this on a voluntary basis, so it's not every technician that are, I would say, that are comfortable doing online streamings in live, and I can understand that, and so I won't push anyone on that. This chip is installed. Let's go and measure if everything is good. Again, we can cool down the board while we're working. Let's put those fans back. And we can go into diode mode. Now remember, red probe to shoot in the ground, and black probe to measure. So that might be confusing if I put this one there. So let's just have the black probe like that to make the measurements. All right. Back on, and maybe let's go back to the microscope there. All right, not too bad of a job. Should go on there. Look at the clock. It's a bit jumping all over the place right now. Okay, we got it. So I'm getting 1142, and again, I should be getting 1200, give or take 20. So this is a bit off diode wise, but at least it tells me that the installation of the chip should be all right. So let's still go and measure the voltage. Before we do so, I'll just give a small cleaning shot there. And so those temperature sensors issues on the 17 series, they're very common. Most of the time they're related to a chip because the circuit of the temperature sensors are integrated into the chip circuit. Unlike the 19 series where the temperature sensors have their own circuit, which is powered by the PIC, this one is powered by the chips themselves. So if the chips values are off, obviously the temperature sensors, the values they'll be getting are going to be off, and that's what is causing normally the issues on temperature sensors. Very, very rarely I actually see a temperature sensor IC fail on the 17 series. Let's put our multimeter into DC voltage measurement. Oh, and let me bring back my this one, or no, I need to go back to this one here, or this one here, so you can see the chip map while I'm doing the testing. And obviously to test, I'm gonna need to have my hashboard plugged in. Best practice, remember, negative first, positive after. Negative always the closer, well, at least until now, always closer to the IO port on the Antminer models. So now my power supply is powered on, 21 volt. I have my tester plugged in. We're ready to start the test. So let's start with a chip level test, standard test. And so at least my installation is good. We still have 30 chips. Amazing. Now let's go and pull the data from the temperature sensors and see what's happening. Still flashing, so there's probably still an issue there. Let's go and measure. I'm at 96 right now, so I had 95 and now I'm at 96, 0.96. So let's try to find maybe the source of that issue is somewhere else. My clock is there, so this is where I have my other clock, 82 there. This way, 93 on this chip there, 91, 90. So here we are. So let me stop the test just 2 seconds. So there is some weird issues that we found sometimes, and it looks like some issues sometimes they're gonna jump from chips to chips, but they're not gonna do a jump like each. I would say they're not gonna jump from one chip to another. They're gonna jump two chips actually. And so sometimes when we try to find the source of an issue, it's a bit weird. The issue is actually, in this case, it's located in these domains, as I said. But the thing is, sometimes what's causing the issue to these domains is coming from another domain, from another chip. And so that's my theory right now with what I'm seeing now, with the changes we did. So we looked at our resistance. I know my capacitors are good. Just by the look of it, they're good. We can always do the testing, but I know they're good. And so my voltage is a bit weird, it's a bit off. And let me show you what I'm actually talking about. So remember, it's sometimes the issues, they are coming from another chips previously, and they're gonna jump in shots of two. And I'm actually not sure exactly what can be causing that issue, but it's some things we notice from time to time, and it looks like this board is doing the exact this exact issue there, where it's jumping from previous domains and it's jumping from two chips. So how we fix it normally is we try to find the source of that issue by going back in jumps of two chips until we find the one that's off. And again, it's a bit of shame that I don't have the right angle for my multimeter there, but I'll fix it for the next stream for sure. And if we need, I'll do another one on the T17 temp sensors. Anyways, I have those two boards there. Also, these are upgraded boards that we upgraded. So it looked like the chips were good, but in the machines they gave us issues. See, the guys that do the testing, they write down to me chain 0 in that case. This one is not written, but they remove it from the machines where the tests were made. And so probably by the looks of it, I won't have time to look at them today. So probably I'll do another streaming, maybe the 5th one or the 6th one. I also have a lot of T17 Plus to go through. Yeah, and in my logs that you don't see in screen right now, I can see that chip 20, well, temperature sensor on chip 22 and 24 stopped replying now. So they're just off now. And that is exactly what we would see in the logs of the unit as well. So yeah, there's still an issue there. Now remember I was saying we'll go back and jump in lots of two. So again, let's make the measurement here. When I look at my DC voltage for the clock values, I'm measuring 94 there, 95 now. If I go back just one chip and I measure this one, I'm looking at 85. This one is within range. If I go back to this chip, so now we're two chips farther, measure, I have 92. 92 here. Now I'll go back one more chip, so now it's a jump of 3. This one should be good. But I'm actually measuring 94, so let's keep it in mind. Back to this one. 88. 91. So it's starting to be a bit less off. Clock is going that way here. 98. But my board is getting very hot now. $86, $93, $91, $87, $89. So now my jump of 2 chips is starting to look good. 93. So there might be more than one issue on this board actually. Here, so this is the clock. 89, 90, 91, still a bit off. Yeah, there it is. 87, 89, this is going there, 89, 88, 88. All right, so let's stop. All right, so we have 1, 2, 3, 4, 5, 6, 7 weird looking chips. I'm pretty sure those 8 chips aren't all bad. So what's happening is there are some, the problem is sourcing at one of those chips and it's jumping instead of 2. And so we have this one here. So 1, 2, 3, 4, 5, 6. 1, 2, nothing, but this one is weird. So it's breaking my rule actually. That's weird. 1, 2, 3, 1, 1, 2. So this one would be compatible. So it's possible this chip is to what? Let's stop that. This one here, this one for this one, it jumps, it doesn't come here. This one for this one, this one for this one, this one for this one, and those two we could discard. Those were off, but not by too much. 91, 91, if I remember correctly. So again, 1, 2, 3, 4, 5, 6. That doesn't match. Follow the trace there. So I would change this one here. This one here. And this one here. So let's start with that. It doesn't look to be the best board to take for that issue. At the same time, it is a good board, you know, to see the kind of issues we're getting daily. Daily, we get some weird boards. It's part of the business. And that is very interesting because, well, those chips you can see they're delaminated. So let me make a close up. So see those chips there, they're very delaminated. So when I ground myself to the heatsink, I'm grounding through that like oxidation. And so the readings sometimes they're very hard on the 17 series because the reading is not exactly accurate, especially because of that oxidation here on the chips. I have the same here. See, like this one was barely holding from that side. There's only that side remaining with 10. This one actually, it's almost surprising that it was still holding. Under it, you have this one here. Also, just the heatsink was holding just by that here. And so, you know what? We'll remove the other heatsinks just to make the measurements again through that. Now, one very nice thing is normally when you have delaminated chips, you're a bit stuck and you have to change those. And that was the case for the past 2 years for us. But we now have a solution, an in-house solution that allows us to retain those chips after a lot of research and development. We're able to fix those chips now. So this is a good cost saver, and this is appreciated in markets as it is right now. Let's put this here. So finally, this chip right there, properly tinned, but all the other ones, they're all delaminated, all oxidized. Let's look at the resistance. Make sure everything is good there. 33, 32, 32, 32, 33, 33, 33, 33, 34, 33, 33, 33, 33, 33, again, it's good. Oh, what do I put this one same? Oh, no, that's alright. 4, that's alright. That's good. And here is good. Alright, so resistance is good. Just want to look at something else there. Yeah. 6. If I look like that, not sure, I just don't want to tell you nothing. Yeah, okay. So I'm gonna ground on the board and look at my return signal resistance just to see if I can find some hints on a bad chip. Normally I should be, let me bring the microscope so you can see. So one small trick you have with the T17 is you can measure the resistance of your return signal, which is the RI signal. This is the touch point, the test point for the RI. So I'll go and ground myself on the board, like that. And I'll measure this value here. And what I should be seeing on the multimeter is 2.5K. And I'm getting 2.5K now. So let's rinse and repeat on, sorry about that. Let's rinse and repeat on each of the chips that we uncovered. Choices coming that way, here. Get the return, 2.5, 2.5, 2.5. This one is good. This one is good. 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 That's all right. So I can find no anomalies with the resistance of my return signal. So this is looking great. But it's a bit weird now because we're not able to pinpoint the source of the issue. Let's actually keep that. Let's redo our voltage measurements, but now with the heatsink stuff. And the reason why I want to redo those measurements is because I noticed that those chips, they're delaminated, they are oxidized, and sometimes the readings that you do on top of those chips are bad. Like the heatsink is not making a proper connection, as I showed just before when we zoomed on the chips, like they're barely touching, they're barely like connected to the chip, and so sometimes our readings, they're a bit weird because of that. So this is why we actually upgrade these boards, you know, with that upgrade there. That's why we're doing that. We just scrap all the heat sinks from those boards, and it will look, when you remove all the heat sinks, something like this, and you can see like more than half of the chips are delaminated on that board. But we do have some solutions to be able to solder tin back on top of the oxidized chips like that. So we have a acidic product that's gonna allow us, when we heat that product, to attach tin on top of the oxidation. So this is very useful. But what's better is to do the upgrade as I showed. Let me see if we have questions in the chat. Hey Osama, for the Eno Silicon miner, and Watts miner as well, I do want to make those streams as well. If you have any model maybe to fix, you can send us just a sample of each of the boards, and I'll gladly do a stream on how to fix those as well. You make me a better person. Well, it's my pleasure, but really we're just all learning all together. I see myself as a student. I don't have a background in electronics myself. I was working more in IT and cybersecurity, and then I've launched my own Bitcoin mining operation back in 2016. And having those issues myself, well, I made a lot of figuring out, and I've learned electronics. I've hired a lot of electronic technicians here, and they teach me a lot, and I'm still learning every day. There's not a week that I'm coming into work that I don't learn something, and I do want to share that with people now. So we're all students. So should we always ground from the side of the board just to be safe? Well, yeah, grounding on the side of the board is really useful when you measure resistance at least. When I measure voltage, I have better measurements if I ground on top of the chip. But the thing is, as I showed, is when you have oxidized chip like that, it can make misreadings. So it's you have, unfortunately, you have to lose some time on those boards, and you know, keep digging deeper until you find your issue. So meter in DC mode. All right, better focus like that. So I'm starting my power supply again at 21 volt, and we'll start the measurement. So starting the test now. Seems like my tester bugged again. Let's start over. So chip level. So I was seeing the 24 chip coming red for one turn. I just wanted to go and see what was the what was happening there, but the values they look good, so I think it's just the tester tripping on that chip for some reason, and that happens. Obviously, sometimes you have misreadings, and they're gonna be coming from one of those chips that are causing the actual issue, and that's the same chip that's causing the issue on the temperature sensors, and that's why we're getting misreadings. And so we really have to localize that issue now. Measure plug there. So still 91. Going there. 94. And so this chip, well, that's weird because see this is the 9 chip, and on the 9 chip, as you can see on the screen there, let me put my mouse there. You can see this chip there. This is the 9th chip, and we have a temperature sensor on this one, and we're not getting misreadings from that temperature sensor. Although our voltage is very high, we're getting 93 now, 94 essentially. Um, so maybe let's try to change that chip and see if that is the source of one of our issues. Although we don't have a jump of 2 on this one. Focus is getting weird sometimes. All right. So we put flux, put this aside for a sec, tweezers, air gun, and we're removing the chip. There we go. Can make the install maybe with the microscope there. So let's clean that. Well, first let's cool it down a bit because we don't want to create any damage. I like to keep my boards clean when I work, like that. Put back some flux, tweezers, and we'll install that chip. I have some recycled chips for that board. I'm pretty sure they're good. They're tested. Oh, and by the way, we're working on our own in-house tester for the chips, so we should be able very shortly to, when we recycle chips, we should be able to test them in our tester. It's gonna give us the chip quality at the chip level directly before we install them on the hashboard, so we don't have to install and figure it out. We'll be able to know before we make the install. And so maybe if that is very useful for people out there, maybe we'll design those for sales. We'll see. I don't know, but yeah, we're working on a custom tester for chips right now. All right, let's clean again a bit. That all clean. Let's go back to our main screen there. That out of the way. Focus is good. It's still a bit hot, so I'll put the fan just under, like that. And let's see. So I had no bad values before this one, so now I don't think that there should be any other source for issues on that chip. So if that chip is still measuring bad, um, well, we'll have to figure it out, which is good. Still a bit warm, but I believe we can start the test. Start at chip level, multimeter in DC mode, and funnily enough, now we're not getting through the 24 chip. All right, let's start by measuring this. Well, actually, we're in. Let's pull the data for the temp sensor at the same time. We're getting 92 now. We're getting 92 now. And this one here is at 91. But it's not jumping to this one here. 90. This one here, so the clock is here. 94. So the next one to respect the theory where it jumps to is this one. Jumps this one. So let's try to change this here and see what happens. I would have to go very, very shortly, so I really wish we're gonna be able to fix that board before I have to go. So I'll try to get a faster pace now because I'm really short on time. All right, I do want to show you this. So my voltage measurements are good now. So this might be the source of one of the issues we're having on this board. So this chip there, we'll go and measure this one there. But this chip, the values are good now. So weirdly enough, I'm only getting there now. But it's possible the chip was still a bit hot. Let's start the test again. Hopefully you see on the screen the multimeter. And now it's getting back to 24. So, and let's pull the temp sensors. So we have the same data. If I look at this one is actually off. But this one here, oh, it's jumping all around. Okay, so now it's stabilized and I'm at 89 now. So this chip looks like this chip here, so you can see. Yeah, this chip, the values is good. If you look at the multimeter on the top right corner, I know the angle is not perfect right now, but you can see that this chip, the values are good now. So and this one is very off now. It's more off than it was. So this turned out to be a much more complicated board than I was expecting. This one here, and we had, I should have measured actually the other one. We had uncovered this one as a potential source for issues too. So let's go and see. So I think we had 2 or 3 sources for issues on this board. But here's, now we're stable at 90, so that should be alright. This one here, now that's no good, 1.8. So again, remember, 1, 2, this one I just measured, it was weird. We have this one, so that might be a source for issues, and we had identified it as a potential before. So let's go ahead and change this one. See if we have any comments. Nathaniel, yo. So that I believe I know that guy. What's up, Nathaniel? Oh, that's actually a bad chip. There we go. Here, here. Alright, so we can see this board is very sick just by the heat of the chip just besides it. We already have another heatsink that failed. We can see that chip is also very delaminated. See this? So this board, it looks like it suffered a lot. So I wasn't expecting that many issues on this board, to be honest, because we had the, if you remember when we started the stream, we had all the 30 chips, and now we can't even get to the 30 chips. But this can be common when you start, changing some chips. Sometimes like the issues, they all start coming up. We'll get to the bottom of it, hopefully in the stream, because I'm getting short on time, but I really want to fix this board on the stream. So this is why I'm speeding up a bit. This one was good. This one going like that. This one we were measuring an issue, and we found that this chip has an issue. Now remember, sometimes we have source of the issues that jump. They jump one chip, so you have this chip. This one will be good. This one will be bad, but it's actually infected by the two chips before it for some reason that I can't explain. Okay, back at 24. That's that. Start temperature sensor reading. Now obviously the board will trip a bit because we're not getting the full signal. Alright, temperature sensors are still off. Let's make the measurements there. Hopefully this fixed it. So our signal is going like that. You can go and look at the previous one. Previous one is alright. 91 off, but not too bad. This one now is at 92. So it's not 1.8. We had 1.8 before. But this one is still off. And it's decently off. We're at 94. So it's getting frustrating. 4. Now this one that we changed. So, oh, actually now I'm at 90 there. 90 there. 89, 90, 87, 90. So this chip, yeah, that was it. So this chip, we had an issue with it. And so it seems that by coming and changing some chips over here, we fixed the source of that issue right there. So this is the first chip that I started working on, and changing it wouldn't fix the issue. And so we came back to localize the source. Now it seems we had more than one problem on that board, and for some reason the signal was flowing through. So to start with, that board, the issue was we have all the chips, but the two temperature sensors here were failing. So we're onto something. Now we can't get to the end of the board. The signal is not going to the end of the board anymore. There's still that shift that was off. So, and we have an issue in that domain where we can't get past that domain here back to the 25th chip. It's possible the 27th is infecting that domain. So we can go and have a look. I'll just let the board cool down a bit. Give it a hand to cool down. So yeah, again, temperature sensors on the 17 series at least, it's almost always chip issues. And as you can see, some of those boards, they can be very sick. Most of the time, it's just one chip in a nearby domain. Now, this board was a bit of a surprise to me because we actually had more issues um, before the three domains here, where we normally localize our temperature sensor issues. So normally we have the domain that has the temperature sensors. It's either going to be a domain before or a domain after that has a chip to change. But this board, it looks sick, so looks like we had more than one intervention to do. So let's start just a chip level test because we can't get past the 24, so I want to try to figure that one out. And maybe once we figure that one out, we're gonna have that issue fixed. So let's go by elimination anyways. 3 is good. Now this one is messing around. 4 is good. Okay, wait a minute. This one here, 90. Now this one is at 93. And we can get past third one there. So my guess would be we have to change the fourth one there. So this is getting annoying because we keep getting back in the board. So this is one of the very frustrating boards. But those boards, they do happen. They're part of the repair job, and you'll for sure get some of the boards that are going to look like that, especially in the 17 series. So let's go through it. And there's some weird stuff on the bottom pads of that chip. I don't know if you can see it correctly on the camera, but it's like maybe some old floods that stick there, or it's weird crap there. You can see some still attached to the chip. We'll just make a quick text because I'm gonna be late. I'm starting my uh, soldering station because I want to make sure that those paths right there, they're cleaner. they're not looking great, so I want to make sure that it's good. Where's my, yeah, there it is. Trucks. Looking great. That's clean. Install a new chip. So one thing to keep in mind is your tester is gonna tell you one thing. As you can see, my tester on the previous test is telling me there's problems all over the board, and it's somewhat true. But what you really want to look at is your measurements, and so the tester is there to guide you, and you want to use um, use that guidance to go and make those measurements and confirm where the issue lies by yourself. Now, this board is very great in a way because it makes you see that some of the boards they can have a lot of issues, a lot of source of issue. Not all the boards are like that. No, some boards you change one chip and all is good. But some boards we do have to change up to 5 chips. Normally we cap our repairs here at Decentral at 5 chips. And some people they don't believe us that that some fixes they require 5 chips. But it does happen. It does happen that a board will require 5 chips or more, man, even. Now, if this one requires more than 5 chips, I might still do it because I really do want to show you guys that the temperature sensors issue are actually a chip issue. But it looks like it's a sick board a bit. And the T17s, T17s and S17 Plus, they seem to be two models that do get a lot of chips to change most of the times when they're broken. And I believe it's because the chips are more stressed. You know, in the T17s, the frequencies are running at about 700 megahertz, and the voltage stress on it is at 17.3 volts when it's running in the machine. The reason why we're testing at 21 volt is because the chip discovery in the units are done at 21 volt, and then the power supply will decrease until it reaches the EEPROM value that is written in your PIC. And if you want to know, your PIC on the 17 on the T17 at least is located right there. So this is where the programming of the hashboard is located, and it's the hashboard that's drawing, that's calling on the power supply. Well, actually, it's communicating to the control board, and the control board is calling the accurate voltage for your hashboards to run on. So the power supply will always start at 21 volt, make its chip discovery, then it will ask the PIC, what value should I be running at? And then the PIC will return the EEPROM values, which in this case, that board is at 17.3 volt. And so the power supply will decrease its voltage until it reaches that voltage, and it starts hashing for you. Let's clean a bit the area. Temperature is good. So let's launch the test. We'll just go with a chip level testing right now. We want to get the signal back to 30, and then we'll attack the temperature sensors again. Okay, so it seems we fixed the issue around the third and the fourth chip. But what we'll do is we'll go and make sure of it. So again, your tester is telling you one thing, but you want to confirm yourself with the measurements. So let's look at the third chip. Third chip, 90. Oh, let me bring the multimeter there so you can see. Again, the angle is not perfect. I'm sorry about that. I'll fix it for the next stream. 91 at the moment. Oh, it's getting back there. 91. 93. This one is weird. So let's go to that domain there. Clock is there. So clock 85. That should be alright. 91. Not perfect, but 91 should pass. 89. Clock is there, so it's gonna be here. Oh, and look at that. We have 1.7 now here, and the 25 chip. I'm measuring on the clock 1.7. Make sure the eye is normal. Clock 1.7. Definitely up. Let's look at the other one. This one I have no clock measurement. 1.7 also on the clock. The clock is going that way, so that would be the source, and we're jumping to. So that chip that we identified at the beginning, it's possible that this chip is causing us issues with it. I feel we're getting to the end of our pain. Let's hope this one is the one. So I already changed the normal did I 1 2 3 4 5 yeah, so normally that board from there on would start to be deemed a no fix. Depends if you have volumes with us. You let's say you have the 10 units or 30 boards with us, and most of your boards we change just one chip, they're all right. And then we have this board that needs 6 or 7 chips, we might still do it, because in that case, all the other boards we saved on the chips. um, but if you have just one machine with us and all of your boards require that amount of chips to be changed, it might be deemed a no fix. So again, I have to speed up a bit because I'm already late to my next appointment. Got some time, but I won't be able to buy too much. I'll have to redo the legs because I moved too much and I made some mistake there. The chip is good, but the pads, I just want them to be more even. So make sure the installation is good. Letting my solder tip reach temperature, 400 degrees. Right, looks even. There you go. Box back and put back the chip. That, that. All right. pretty out on the bottom. On the 19 series, you have no choice but to remove the heat sinks under the dashboard, but on the 17 series, really, most of the time we skip that part because it's not necessary. It's a bit hard because I worked more on that area. All I'll do is I'll spray some alcohol right there. All right, let's go back to that board. Go back to testing the chips, chip level testing. On, that's on. Bring it back on the screen. Oh, no power. My bad. Let's power on the board. 21 volts. Start the test again. And let's see. Still not going through. I'm starting to miss a lot of time. 8. Clock here is 1.6. What's happening there? Okay, let's go and measure. Oh, that's no good. Alright, so what I did, obviously, as you saw, it was a decent burn. So I powered off my power supply. So there it's done. Booster circuit just burnt. The booster circuit just burnt. Let's see something. Diode test. I also my let me just go and grab some values. I'm not sure. Resources. So let me try to bring this on screen. That. All right, and let's try to zoom a bit so we can see. That's no good, but these things happen. So let's go and try to find T17. T17 here, LDO. So what I was about to do when I flipped my board like that is I was to go and measure my LDO, because I was wondering if I get 1.7 on the clock, is there an issue with my LDO? And so I wanted to flip here and come and measure my directly to my LDOs. What I should have done, honestly, is just keep that board here and measure directly on the capacitors that are fed the 1.8 and the 0.8 volt line. But anyways, what happened? Let's just measure the resistance of those lines. So LDO 1.8. Here. 71. So my resistance values are a bit off on the looking to be off on the LDOs as well. So what I should be measuring, as you can see on screen, I should be measuring 400 give or take 20 and 20 give or take 5. But what I'm measuring is actually 40 on the 0.8 volt line. And I'm measuring 470 on the 1.8 volt line. So listen, I have to go now because I have some other appointments to go and do. But what I'll do is I won't touch that board again today, and hopefully tomorrow tomorrow or Friday. So tomorrow I'll do it. We'll do another stream. We'll fix that boost circuit that I just burned, because we can still fix that. That's no issue. And we'll figure out what's happening on that line here. But I can't do that today. Very sorry about that. So I really do hope you still like that stream, even though it's no fix for now. We'll see again. We'll see each other again in the next stream, hopefully, and we'll fix that booster board that we just burnt now, and we'll fix the LDO line, because I believe that might be the issue we're having here. All in all, that board seems to be a lot of trouble. It looked all right when we started to do just a chip level measurement. But there are boards like that where it feels like each time you change something, the issues, they just get worse and worse. But what we could confirm is we're actually getting better and better with the measurements. The tester is giving us some weird issues there, because well, maybe on that line, by doing the testing, we created more damage because we keep injecting voltage and keep injecting more voltage. And I'm not sure exactly what caused the boost circuit to burn there, but it does happen. It happens to the best of us. So really, don't let that discourage you. I don't let that discourage me either. Again, hopefully, uh, hopefully you still like that stream, and really sorry we couldn't fix that board tonight. So tomorrow I'm gonna work on that board again. I won't touch it. It's gonna stay like that, and we'll fix the boost circuit. We'll fix that line there, and we'll get to the best of our temperature sensors. Don't lose hope. Not all boards look like this one, and I do have those two other boards here that we've made an upgrade like this, and we'll get to those temperature sensors as well. So see this one? I have a note here. It says temperature sensors on that line here. So we'll go and have a look. Most of the time, we change just one chip and the problem is solved. Some other times, there are some mess like that. One thing that I can tell is that often these boards are the ones that have been overclocked. So it's possible that this board was running some after sale firmware, and so that's why you'll see some chips that receives more stress, and so the values they get off because those chips get much more used. um so yeah, anyways, hopefully you like the stream, and let's see again each other tomorrow to fix that board once and for all. Cheers guys, thank you for watching.